Hello everybody and welcome to the stream. If you haven't already, please toss me a follow on Instagram and Twitter. See those accounts linked there, and then also a follow here on Twitch if you like what you see. Encourages me to keep doing what I'm doing. Awesome. So today we are going to do a whole collection of things around the 2D plotter, which I've got here on my desk. A lot going on here. We're going to first start. So in a previous segment, we mounted a switch here for determining when this bit came over here and tapped here, which I don't even think the switch is even hitting. Whoops. So that's bug number one. And then we are going to add a second switch, or we're going to add the second switch here, and then that'll get rid of the soldering iron. We can take that away for a bit, and then we're going to start connecting these motors. One off camera, right over here, and then this one to this breadboard. And once the wiring is all set up, we're going to start trying to write some code so that we can output Python commands from Python and send them directly to the Arduino. So first up, we're going to, I wonder if I need to flip, let's see. Okay, first let's detach this switch on this side because I think I put the wrong one in. So I'm just going to grab some of my Allen keys because I don't know what sides we need. Put those down there. All right, let's see what we need to do. No. Cool. Try not to get myself too much in the way here. Doing the overhead webcam thing is a bit new to me. All right, so now if we flip this right way up, I believe this should just attach in here nicely. Okay, hopefully this actually hits the switch now, which it does. Awesome. Cool. Screw in the other side. Awesome. Okay. So that's fixed, and now we want to attach this other switch on top here, because that will get hit when this piece that eventually sits here will slide along, and we'll tap in to that switch. So right there is where we want to put it. We're going to need to enlarge these holes up top with the drill. So let's get out a drill and some bits. Basically what we're going to do is we're going to heat up some of these metal bits, which we can push directly in here with a soldering iron. That's similar to what we did over on the other side. I believe they were M2s. Let's double check. I've just got a ton of screws and things on my desk. Let's see if we can rotate the camera around a little bit. Cool. All right. So I want an M2. I have to unscrew one of those screws real quick just to see what size it was, because I don't remember. All right, so this screw, let's check if it's M2. I believe it's M2. And And it is, so it's an M2 screw, so we're going to want another 2 M2 screws. And this, get out our calipers. So we can measure the length of this screw. This screw is of length. Whoop. It's about 9 millimeters, 10 millimeters. We don't have either of those measurements. We have M2 by 8 though. Yeah, these are M2 by 8s. Okay, cool. So we'll grab 2 more of these. One and 2. Cool. We're done with this kit. Throw this back on my shelf, so we'll try and kind of clean up as we go so I don't make too much of a mess. Awesome. All right. So now we need to pick out some of these heated bits. And so I want to look at the previous one for comparison. I really should have written these down. Those, okay. Go with these guys. These are M2s, so we'll take 2 of these out. Let's put these back on the shelf. We can screw this other screw back in because we don't need it anymore. Okay, cool. So now we need to attach these lovely little soldering iron bits to our soldering iron so we can press these plastic, or I can press these into plastic. Take our smallest one. We'll change the bit. And lastly, we're going to want to drill a little hole to remove some of the excess plastic. So I'm going to choose a little drill bit. I'm going to compare the drill bit to the diameter of this, that should be good to remove material, but leave enough plastic that these little bits you kind of can't see can attach to. All right. Going to mute myself real quick. Perfect. So we removed, I think, enough material that we should be able to turn the soldering iron, press those metal bits down, and we'll be good. So we'll pop our soldering iron on. See if we can't bring the webcam down close up, see what we're doing here. Cool. All right. Let's bring it back to this a little bit. Gonna grab my trusty Leatherman so I don't burn myself while holding these because the soldering iron is hot. All right, soldering iron is heated up. Oh man, it's a little hard to hold with the amount of coffee that I drank today. All right, that should be good. Oh man, this is gonna be a fun task with coffee I've had. All right, I think I've got it though. Come on, you know you want to go in. Cool. Got that first one stuck in. Now to do the next one. Sorry, hands in the way. It's not the most fun task to do. Cool. All right, so now should be able to run those screws through our switch. Cool. First one is in. Okay, that is unfortunately, I think I screwed up putting this little plastic bit, or the little metal brass bit in there. Extruded too much plastic into the brass bit. Yeah, that hole might be completely ruined. I wonder if we can remove it out and replace it with a different brass bit. Sorry for the hand. Let's bring it back up. Sorry, I'm not used to using this little thing to organize my webcam. Oh, burned a hole. Okay, I think that's totally stuck in there. Whoops, okay. Basically, I think we should be able to tighten down this one screw enough to not need the other one, but lesson learned. Yeah, that's tight enough that that's not going anywhere. Cool. All right, so we don't need the soldering iron anymore. We're going to rotate our camera back around. Cool. So now I'm going to separate this out so that we can slide our last bit through the middle. Cool. Cool. So now we have the whole plotter. This part can move along here, and then this one can move stubbornly along this back axis, back rail, I mean. Cool, perfect. And boop. All right. So let's let the soldering iron cool down. While we do that, we're going to attach our belt to this main bit here. Our other belt, I should say. So we're going to grab that out. All right, so one thing real quick, I actually want to detach this here. So underneath here, this channel is where these belts are going to fit, and they're going to fit kind of just like this in there. I totally didn't model this part the way I thought I wanted to. So that's a whoops. I think we'll just get away and leave it as it is for now. This is fine. Oop. Bear with me 1 second. So we're going to attach our belt. We're going to want some binder clips, some trusty binder clips, make everything easier. See if we can't get away with one giant binder clip. All right. Turn our belt around. How do I want to do this? Cool. All right. So now I've got the belt wrapped around. Going to slide it in that little channel I was pointing at. If I can get it in there. This could use some improvement. Okay, cool. Now it's in. Okay, so now we can wrap it around. Now I gotta feed it in the other side. Ooh, no, not quite. Come on. Okay, sweet. Now it's in. Now we can wrap it around the sides and use our binder clip to keep it in place. I don't know if this binder clip will open up this wide. It does. Sweet. All right. Cool. That's mostly tight. Trying to add some more tension in here. Cool. So let's see. So now this belt moves that. It actually feels pretty good. Cool. All right. So now I got 2 motor set up. So we don't need this M2x8, so we'll throw this back in the box. We also don't need our Allen keys anymore. Whoop, almost just dropped all the nuts around the screws on the floor. Perfect. All right, so grab our Allen keys. And put them back. Chat, if you have any questions about what's going on, feel free to ask. Today we're building a 2D plotter. Basically just something that can move in the X and Y directions and then attach something at the head. So for us, we're going to attach a pen eventually so that we can print out on a paper. So eventually here we'll set a pen and then we can kind of move around in the X and then we can go in the Y. Yeah. Yeah, most of this work was just for that first step. Let's see this still. Oh, cool. Let's just finish this part with the Leatherman. Just changing the bit. I like to set my bit on my soldering iron back to the main bit before I put it away. All right, cool. Let's get this out of the way. Just gotta unplug it and then we'll throw it back on the shelf. Oop, cool. So nice to have less things than you need on your desk. or only have the things you need, I should say. Okay, cool. So, just grabbing some other things that I know we will need soon. Also, these bits can go back away, and so can the drill. I guess we can call this intermission time, so if you have any questions, please do throw them in chat. I do need a few more minutes to finish getting set up. Otherwise, I guess y'all can just watch me clean up my desk and declutter it. All right, what else do we need? All right. So I was just thinking as I was organizing things, I want to do a little bit of a test with, I like to test things kind of in separation, and so we're going to use this board here, basically create a little D-pad, and a D-pad is just an up, down, left, right, that we can use to kind of make these two motors here, actually move up and down and left and right. And then once we get this working, we can kind of drop and replace with our Python code and start setting other instructions. So what else do we need? Oh, we're gonna, oh, we totally still need to do soldering. Whoops. Apologies while I rustle around in my bin of stuff real quick. Cool, so I'm really just grabbing wires. Oh man, I do not keep my stuff clean. Sorry, I should say organized. Alright, we got our wire. We're going to want to wire the wire up to the motors so we can actually attach it to the Arduino, because right now the endings on these wires do not play nicely. And we'll also need solder, and that should be it for this bin. So I'm actually going to pull the soldering iron back out. Plug it back in. Alright. Cool. So what we're going to need to do is I've already prepped the other set of wires. So these you can already see have electrical tape and connectors that will go to the Arduino. But I'm going to need to clean up this guy. So first we'll want to trim all four of them. Cool. All right, so now they're trimmed, and what we're going to want a green, a red, a gray, and a yellow. So we'll replace gray with white. We're going to want to strip off bits of wire that we can attach to these motors. Go a little bit longer so we have some wiggle room. Because this let's see. So this motor is stationary, whereas this one's going to be sliding back and forth. And so this one is going to have a longer cable, so we're going to want to cut out a little bit longer in length. So we don't have to worry about that. So let's go that long is good. Same for red. Same for green. And same for yellow. Cool. And we'll want to trim these as well. By the way, if you like what you're seeing, would appreciate if you toss me a follow here on Twitch. Keeps me motivated to do these kind of things. And if you like or don't like what you see, I have a little feedback form down below, which I request that you fill out. Would always love your input. Okay. So we've cleared off each of these ends, and we're going to do this one at a time. We're going to solder these on. So we're going to turn on our soldering iron again. Find the power button. Okay. Cool. Kind of a little technique down that I've learned throughout the years. So it's kind of hard to see, but basically we crisscross them, and then we bring the one side down like this, and then we bring the other side down like that, and then we just keep wrapping them around. So, since I don't care too much about this desk, I'm just going to do this right on the surface. Now we're just going to run some solder over that line. Cool. And now we're just going to repeat that 3 more times. Cool. All right. Next up, we'll do white. Cool. Cool. 2 down, 2 to go. I don't know why, but my nose itches so much just when I stream. Cool. All right. And yellow. Cool. All right, so that should be strong enough. Let's turn our soldering iron off, and now we'll just run some electrical tape after I clean up the mess that I made with my wires. Cool. All right, so we can throw these back in the bin. Let's just leave this stuff out in case I need to come back and redo something, actually. Okay. So now we'll just want to wrap up each of those open connections with a little bit of electrical tape for some extra strength, and also to make sure that they don't come in contact with each other. All right, one down, 3 more to go, and then we should be ready to hook this up to the Arduino. Very excited. I feel like today might be a huge milestone for actually getting all these things working together. Man, I've been working on this thing for almost 2 months now. Alright, just need to close out the red, and then we're good to switch the Arduino. Sweet. Alright. Toss this to the back. Let's clear off our workspace of all these little snippets. Cool. Alright, don't need this anymore. So, let's pop back up in the a little bit. That should give you an interesting overview of everything we need. I'm going to put the soldering iron back on the shelf and get that out of our way. Okay, cool. So now, let's finish wiring up this board. Don't need these anymore. Actually, we still do. Let's see, does this hit when it comes down? It does. That's cool. All right. All right, let's see. So we're going to need to run. This wiring is going to be a pain in the butt, I know it. All right, let's just put it all here. So we're not going to wire up this guy for now, so we'll just push him out of the way. We're going to want to wire up these 2 switches. So let me get out my multimeter because I don't actually remember how these switches are connected. Alright, so we'll attach one here in the middle and one on the edge. And I'll be able to use a lovely little function on my multimeter that will beep if they are connected currently. So it looks like they're not, but if I move over to the other one, cool, interesting. Okay. So what you're hearing is, I bet if I press the switch down, it'll stop. Which means we want to check to see when this switch is actually down. It's these 2. It's the first 2 that get connected. So I'm going to sketch that out real quick. So 1, 2, and 3. So we'll say 1, 2, and 3. And so when 1 and 2, so down. So when 1 and 2, and up is when 1 and 3. Cool. So we'll use that for code later. So we're going to run connections to these 2. Oh, wait, no, these are from the multimeter. Don't need this anymore. Alright, we'll throw the multimeter to the side, and so now we're going to get a white. Actually, let's go red, black, and green. And we'll connect these to the one set of switches. Cool. And we'll put these over here to our breadboard. We will do another set of red, black, and green to the other switch. So let's see. Red will be the bottom one. Oh, these are slippery. Okay, so it's red, and then it's black, and then it's green. Cool. Get these other ones out of the way for now. Might not actually need them. Okay, and then we can run these underneath over to here. And lastly, we'll run the servos underneath over to here. And these can run underneath as well. Cool. Okay. Don't actually need this board. I'm going to move this out of the way. Okay. Let's bring the board back. Just kidding. Okay, so grab a handful of smaller wires out, because these are not actually set up. These alligator clips are not set up to connect to the breadboard either. So, go to my trusty little wire kit and connect each of these with a little wire. I generally try and keep my colors separate for wires, and kind of have like one always be for ground and one always be for 5 volts and one always be for different things, which I'm doing with the actual cables red, black, and green, but not doing in the little bits at the end. Just a little note to myself. All right, I think we have all of them connected. Perfect. All right. So now, stick the Arduino Uno there. We will wire it up, and we'll write some test scripts to check each of the switches independently, and then we will write a little script that does the motors, and then we'll connect it to our little button board to have some inputs. Okay. Okay, cool. Oh, I didn't want it to drag along. Okay, this should give it enough slack. Cool, okay. So first we'll want to grab out some more wires. My wires are a mess. Okay. Alright, so let's grab 5 volts on the Arduino. That's not 5 volts. That's 5 volts, and this is ground. and we will connect those to the middle rail. Let's try and get the Arduino out of the way up here. Perfect. 5 volts and ground. Cool. All right. So now, if we switch over to screen and desk, gonna open this up. We're gonna create a new one. Chat, if you can't read that, let me know. Otherwise, I think we should be good to go. All right, so our first variable will be xSwitch. xSwitch pin. We'll put that on 3. Put ySwitch pin. Put it on 4. And we will make the pin mode for xSwitch pin to be an input because we're going to receive information from it. We're going to duplicate this line, do the ySwitch pin, and we will read. So let's call this is xSwitch on, and that will equal digital read switch pin. There's the Y on, and then we will Bubba, thank you for the follow. Much appreciated. We want to begin. Okay. And then we're just going to want to print out I can't remember if print line will take multiple inputs. We'll find out. And then we'll do this once every 50 milliseconds. Okay. That is possible. So let's connect to our Arduino. I think it's on COM11. Let's see if we watch the Arduino flicker, which we can see. It has now received the code. And now if we open the serial monitor. Okay, that's bizarre. I can't shrink the serial window. I really can't shrink the serial window. What is happening? Okay, I guess it's just going to be this tall. That's not what we want. Okay, what happens if we read just one value? Oops. Okay, that's cool. All right, so then we'll just print ySwitch. Replicate that. Okay, that should be good. All right, so X is saying 1 and Y is saying 0. Do either of them work? Right, because they're not hooked up. Oh, man. Okay, cool. So I believe I need red should go to 5 volts. Green should go to ground. And then we'll plug in the last one. What do we say? We'll say this motion is X, so X is on pin 3. So 0, 1, 2, 0, 1, 2, 3. Cool. Okay. It's floating. I think I wired that wrong. Okay. Let me grab one more switch out of the box. I think it had a little circuit diagram of how to wire the thing up. Oh, okay. So it says the 3 pins say NC, NO, and G. I don't know what any of those mean. NCO, NO, and G. Ah, here we go. It's normally open, normally closed. Why would I have both? Oh, and C is the contact. Okay. So if I read that right, I think red should actually be the pin that goes to the Arduino. 0, 1, 2, 3. And the other two should go to like this. Okay. So now, hopefully if I hit this, nothing happens. What am I doing wrong here? They're not shorting. Is the breadboard getting... Oh, the breadboard's getting ground and ground. Whoops, that should be one more pin up. Okay. Now does it work? Yes! Alright, so we're looking at X here. Y is still not connected, and that's fine. Okay, so we're going to take our other switch and put that to pin 4, and then we're going to take black and put it over next to the other black, and green over to the next to the other green one. Cool. Alright, so now the Y switch turns on, and then it turns off. The X switch turns on, and turns off. Y'all can't really see what I'm doing. Let's see if we can get this webcam a little bit better positioned. Cool, that should be fine. Okay, so now we're seeing that is affecting the code, and then we can push them even together, and we can read it, and everything's good. Even better, if I wire this up, see how this goes, I should be able to slide this over. Ooh. And Y, X turn, oh gosh, wait. So X and Y are off. Oh, it doesn't, okay. I didn't print this position well enough. It like just wants to toggle it on. It almost works. And then the other bit would slide down. This would slide in here and tap in to turn that on. Interesting. Oh, that's like ever so slightly off. Okay, so I think we're going to cheat a little bit because I don't want to reprint things. And I'm going to unscrew the switch over here, just the top one, so that I can rotate it forward. I'm just going to completely remove the top one, actually. So just one screw's holding it in, and then we're going to tilt it forward a little bit, and then tighten the bottom one a lot more. If I did that right. This will now trigger the Y. Perfect. So now we can come over here and we can connect there, and then we can connect here, and then we know that we are at home. Beautiful moment. Beautiful moment. That's cool. Cool, cool, cool. All right. So now, let's wire up our stepper motors. Okay, so we said, oh man, I took a photo of this on my phone because I knew we had to go research the ordering the wires and how to connect them to the Arduino. I have no idea where my phone is. Is it under this pile of stuff? Oh, it's in my pocket. Cool. All right. Chat, if you have any questions while I'm pulling up this photo for reference, feel free to throw it in chat. Okay, here it is. So the ordering is green, white, red, and then yellow. So we're going to connect each of the steppers in that order. Green, white. Oh man, this is getting messy. Okay, green. White, red, and then yellow. Okay. So those are on pins 5, 6, 7, and 8. And so if we close out here and we get rid of this and we come back here, we're going to do a new sketch. And we're going to actually grab one of the examples for doing stepper motors. Okay. So we want to modify this. So we said it was what? 6, 7, 8, 9. 6, 7, 8, 9. And what it'll do, it'll step once at a time, one step every 500 milliseconds. So if we did that right, we should see the X direction step once every 500 milliseconds. Oh, that is very subtle. Let's do it 5 at a time. I can't tell if, I think the code is messed up. Green, white, red, yellow. That's what I said, right? Let's check my phone. Didn't actually share the code for this with myself, which was maybe silly. Okay, let's look at this real quick. Okay. 5, 6, 7, and 8. And that's what I believe we wrote in. That is not what we wrote in. All right, whoops. Cool. So now we can see it. It's slowly, it's kind of hard to notice, but it's slowly moving that way. I wonder if we set it to like 10. Actually, let's do 5 every 50 milliseconds and upload that. Cool. You can see it slowly moving, which is nice. What if we set it to 25 and we went -5 steps? Nice. All right, let's stop this before it runs into the wall. Okay. So we got that one wired up. Now let's wire up the other motor. All right, so what was it? It was green, white, red, and then yellow. Okay. So green, white. Just push the red away. This one, cool. Red, and then yellow. Cool. All right, so let's see what we want. Let's try and just set this up just for that one now. So those are going to be on pins 9, 10, 11, and 12. Are we sure about that? No. I totally left a space. I'm so bad at putting things in the proper order into the breadboard. 10, 11, 12, 13. All right, so let's upload this. Let's change it back to positive because negative is going to throw it right into the wall. Let's see what happens. Hopefully this starts moving this way. Oh, yes, because I unplugged the yard. Oh, heck. Okay. Because there's still... Okay, so the thing I just realized is there's still code on here, which is going to force this one. Let's move this one into the middle. Otherwise, the code's going to start running as soon as I plug this in. Yep, it's running. Let's upload this. Cool. And now it's going to stop. Oh, that is going into the wall. No. Okay. Good bit of note. Let's move it out a bit. Hit the upload button. Quick. And now it should go the other way. And it gets stuck. Interesting. Okay. This is something I know I need to work on. Awesome. All right, so let's stop this. Comment it out, upload a blank sketch. All right, so I think what we want to do is we want to have it just see if we can get this to just make this thing right here move into a block. Quarantine Boy, thank you for the follow. Okay. So now, oh man, I need to tighten. There we go. Okay. Moment of truth. So we want to write a sketch that will Okay, so the motor that moves things, let's bring this up a little bit actually. So the motor that moves things in the X direction is this. This is a little confusing. So this switch stops motion in the Y direction. No. Okay, these both can, let me think about this. Let's think about the motors first. So this motion, this motor is X. I'm actually just going to add a Sharpie and write on the top of it so I don't have to keep guessing. So this is going to be X, and this is going to be Y. Cool. All right. So with that, we know that X stepper is connected to here. Apologies for the terrible variable names. And this was connected to 5, 6, 7, 8. And so we'll have the X step count. And the Y step count. And what I want this to do is just basically move in a square, repeating. So, oops, sorry about that. Let's leave all that there. All right, so what do we want to do? We want to start the X and the Y direction are 0. And so we'll say, let's start moving the X direction work first. And we'll set that to true. And bool stepping Y direction to be false. So if we are stepping in the X direction, we'll do X stepper dot step 5. We will also delay, and we will also increase the X step count by 5. We'll get this to just oscillate back and forth first, and then we'll figure out the Y. So we'll need actually another Boolean for each, whether we're going in the positive or negative direction. So stepping X, we'll say positively. And we'll comment this out for now. So we'll need some way to go step positive 5 or negative 5. So do int step count. So we'll declare that there. And we'll go if, there's probably a better way to do this, but this works for me. So if we're stepping positively, X current step equals 5. And we'll throw that in there instead. Otherwise, X current step will equal negative 5. Okay. And last bit is we want to check we'll copy this structure and we'll kind of rework it. If actually we don't want the else case. Let's just do this from scratch. Also, I'm going to have to, I'm just going to switch over to screen so I can enlarge or decrease the size a little bit. Okay. We can delete all this. So let's see. So if X current step, no, if X step count is greater than or equal to 100, we will set the X, the stepping X direction to be, oh no, stepping positively. equal not stepping the previous. Oh, because we can actually do or if x step count is less than or equal to 0. So we'll just go back and forth between 0 and 100. And this should be everything we need. Let's find out. I definitely missed some semicolons. All right, let's switch back to the desk. All right, so it's moving one way. It's getting stuck. That's okay. And it's not going to reset itself. What is happening? It still wants to move that direction. Okay, so I did something wrong. We'll disconnect it. We'll switch back to the screen. All right. So we probably should have just been outputting x step count to debug. Cool. Let's move our motor back over. Let's upload this, and let's bring up the serial monitor. Port is not available. Yes, because we unplugged it. We'll do screen and desk. Whoa. Okay, that's not correct at all. Interesting. Okay. So why is it just jumping all the way up? So stepping x direction is always going to be true, so that's fine. Stepping x positively. I wonder if it's in here. I think this is not actually doing, I think this negative sign is not actually doing what I think it's doing. And let's move ever so more slowly, so I don't have to keep racing to get this thing. Okay. Okay, so it looks like we're not switching directions, which is the issue. Okay, so okay, yes, I guess that's what I was looking for. Wait, is that what I want? Oh, nope, this isn't even. Is it this one? This one. I think it's somehow. I'm so confused. See what the x current step is. Oh, let's bring this back to the middle. Plug it back in. Okay, so it's stepping positively, and it's still stepping positively, even though we're switching directions. I'm confused. I feel like this if-else statement is kind of just trying to shortcut, and I think that's actually maybe not the best. So I think we're going to duplicate this and split out the logic. So this can go away here, and this can go away here, and this will just be false, and this will be true. All right, I think this will work. All right, so what do we got? It's increasing, it gets to 100, and it keeps increasing. So that wasn't it. What? So this is what we're printing out. It gets above 100. And that just continues to be... There's probably something really simple here that I'm totally missing, and I'm not sure what it is. Hello, Tib. Welcome to the chat. Welcome to the channel. We're debugging, doing the most exciting thing one can do when writing code. This is C++. Currently confused why... I'll show you where I'm at. All right, so basically what we're trying to do is get this motor that is now moved off the screen. Let's disconnect real quick and slide the motor back. Cool. We're trying to get this motor to move 100 in one direction and 100 in the other. And so the code that we have... Can I hide the bottom part? Guess not. Okay, we'll switch over to the screen. So we are stepping... We're starting with the x step count equal to 0. And we're coming in here and we're stepping... This is always true, so this doesn't even... Let's simplify things down. So if true... We have an int called current step. Maybe if we declare this outside of here. Actually, it doesn't even really need to be declared in the loop, to be honest. Okay. So if true, which is true, and if we're stepping positively, we're going to increase the x step, or we're stepping by 5 in the positive direction. If we're not stepping positive 5, we're going to set this to -5. And then we're going to increase by that x value and keep track of that x value. And if that total x value gets greater than 100, we're going to set the stepping positively to be false. So now when we come in to here, it should get -5. For whatever reason, it just keeps incrementing itself. If I plug the Arduino back in and upload this new stuff, go over to our serial monitor. So we see it's increasing to 100, and then it just keeps going past 100. And it keeps stepping positive 5. And that value should be decreasing. So I'm very confused. Okay. Question, it should get to 100 and then decrease. Yes, that is the hope. Which I believe by setting, so when it's greater than 100, we are now going to step positively to be false. And then it'll come up here, and this should return -5. Why don't I happen? Right, it's not plugged in. All right. Slide it back over. What? Okay, I'm gonna hit the reset on the Arduino, which doesn't seem to want to do anything. There we go. All right, I think I'm gonna do myself a favor and stop stepping for now, so I don't have to keep unplugging the Arduino. Oh man, this is one of those days where I feel like I'm questioning everything. I feel like I've maybe been sitting here for too long. Okay, so X step it. Why is this not getting set? Oh my gosh. I'm seriously questioning my sanity right now. All right, I feel like I almost want to scratch all this code and start again. All right. Okay. So we'll do Boolean. So if we're stepping positively, got an off-topic question. I'm trying to make Snake by myself after making Pong with tutorials. What language are you doing it in? Are you looking for a place to do it, or like, sorry, I might have beat you to the question. I can't think about a way to make the snake have its tail follow it. Interesting question. So I think what you'd want to keep track of is you're using a square as a snake. So I think that there's a data structure that you want called a queue. Is it a queue? So I think it's from collections, import to DQ, yes. So this is the version of Python. Okay. And so your snake, so you'll have a DQ. I'll do this in kind of pseudo-Python, but so you have some kind of while loop, and your DQ will always be. Actually, we could just do a list for now. So we have my snake equals this, and then it could be like a set of positions. So the snake starts at like an XY position of 1, 1. And you'll basically want to make sure that your snake is always as long as your array. So when your snake is just a square, this number will always be kind of wherever the snake is. So if the snake moves over one position in the X, this would just change to 2. If it moved over 1 again, and 3. If it moved up in the Y, this would become 2. So basically what will happen is now when you have 2 positions, or two bits to the snake, you can say that the first element is always the head. So say the snake starts at 1, 1, and then you gobble a piece of food at 1, 1. So the gobble happens, and now your snake, maybe you gobbled at 2, 1. So now the head is 2, 1, and you'll know that the previous position is now where we want to add the new bit. So you would go like that. And then as your snake maybe moves to 3, 1, this would now become 3, 1, and then you'll see how the values start to shift 1 to the right. So this, at this point, would get removed, and 2, 1 would become where the old bit was. So that would be my first thought on how you might do that. Does that make sense? Cool. Yeah, so I think you would just, for each position in your snake in Pygame, you could just loop through and draw it. I'm pretty bad at games and kind of refreshing them and making sure they run pretty smoothly, so you might want to do some more research there. But yeah. Cool. All right. Thank you for the break. Hopefully I'm feeling recharged to solve this problem now. Okay. All right. This is as sane as we can get, I think. We're just going to print out x at the end. Should hopefully get up to 100 and then go back down. And then just go to negative infinity. It does. Okay. Cool. I wonder if I can do this then. Hopefully this will do the same thing. Perfect. So then I think we can come back and add our and. If x is less than 0, we will change the direction. And we'll add a delay so we can actually see anything. Okay, cool. Yikes. All right. think maybe if we just put this in here, do -5 there. Cool. Moment of truth. Oh, perfect. Love it. There must have been some silly little mistake or thing that I did not notice in my code. All right. So let's upload some code that doesn't cause it to jump around like that. Cool. 100 felt a little too small to really see the motion. So maybe we'll go 200. And now we're just going to replicate this code for y. So y at stopping 0, stepping positively. Okay, we need to actually rename this real quick. So x stepping positively. Let's rename this x positive. Okay. Cool. So now we'll have an is y positive. Actually, no, we need a is stepping x first. And we'll first just set that to true. And we'll want to indent all this code. All right. So what we have here is this whole block now says if we're stepping in the x. And this is true. So this should still just do the same thing. Cool. Sorry, I should have jumped over the desk. We got that nice linear motion, up and down. So we're going to want to repeat all this code. Actually, just everything in here, because we can just do an else condition. We'll paste that all in there, and now just replace all this with y's. Okay. This should still do the exact same thing. We haven't declared is y positive. That is true. All right. Same behavior. Perfect. Actually, we're only using is x stepping. So we don't need this because it's never used. Oh, no. This one. Cool. All right. This should still have the same behavior. Getting close. I'm feeling it. Perfect. Okay. So now we want to change is x positive to, or sorry, is x stepping. Let's separate this out. To false, and we should see the other motor move. Perfect. All right. So now we're going to want to toggle between the x and the y, and I think we could do it in here. So every time we get into this block where we've reached the maximum or minimum of where we want to move, we'll just set this to be not what it was. And we'll want to do the same down in this block, down here, and this should be it. I can't even tell what's happening. Okay, I wonder if I'm going to decrease the delay, increase the steps. 25 actually felt good enough. Let's just do that. Okay, besides the fact that it's really jerky, let's disconnect this real quick. Cool. All right, let's see if I can stretch these out. I really need to figure out the motion here. Oh, this popped out. All right, all right. Really is stuck on the other side here. Womp, womp, womp. See, sometimes motion's nice, and then sometimes it's not. So like right here, the motion's actually pretty nice. So let's try this and see how this works. Let's go bold and even drop down to 10. And we'll reconnect it. Is it really a full rotation? Interesting. Let's try 400. That's cool. Except it really doesn't like moving on the other side here. Interesting. Latib asks, what's your dream job, dream company, or something like that? Good question. I think if I could build and teach, if I could do whatever this is that I'm doing right now, like full time, I have this dream of trying to launch a Kickstarter at some point, which actually I think once I finish the Cheesy Platter, I'm going to try and do, and see if I can't launch a startup over Twitch and document the entire process as I go. So I like to do a lot of the CAD, the code, and the circuits, and so doing it and making it and selling it and all that good stuff and educating others while doing it would be awesome. How about you? What is your dream job? Just popping a quick recording in the chat. Or sorry, on my phone so I can share on Instagram later. All right, I think we're not going to use the little button board that I had wanted to use. For fun fact, I actually launched a Kickstarter, and this guy was what I made. It's my first Kickstarter that I launched, called the button board. Simple little circuit board for using buttons with projects. Lawtip says, I would like to be part of the space industry, part of Rocket Computer Software. Pretty cool. I never really got a chance to make any rockets or anything, but that would be a fun project. My queue of projects to do is always way too long. What is the button board for? It is a way to connect. Actually, let's see what she said. We're doing research in computer science. Man, yeah, in a scientific way. Yeah, that'd be fascinating. Research in computer science always blows my mind. I read books about computer science sometimes, and I always just go, "Oh my gosh, this is like how we went from like zeros and ones in electricity all the way up to like Google Chrome, just like crazy." Um, the button board is a way to just kind of add inputs to a project, because inputs are not that fun and they're a pain in the butt to wire up. So a little workaround for that. Quantum computers and their algorithms. Quantum computer. Okay, that's pretty wild. Yeah, my math coworker, who's like wicked smart with math and stuff that I can't even understand, he talks about the things that are going on with quantum computers these days, and I was like, I don't get it. I like to keep to the simple stuff. Awesome. So, yeah, it blows my mind too. What do I want to do with this? I've been going for like 4.5 hours straight. I'm trying to think. I don't know if I need a break. I think I've been going for too long. All right, so I guess we didn't get to everything. We did achieve our first goal, so this is actually a good stopping point. Cool. I'm a little, clearly, as you can see, a little fried, and I still need to prepare slides for the workshops that I'm doing tomorrow. So, on that note, a few quick bits. For those in chat that don't know, I'm doing a week-long series of CAD code and circuits happening every day, Monday to Friday this week, starting at 12 p.m. Eastern Time in the U.S. Tomorrow we'll be reviewing circuits and learning how to do kind of the stuff that I was doing today. Wednesday will be kind of an open day. Thursday we'll do CAD, and then Friday we'll kind of combine all the things together. So check out the description down below in the About section. Also, if you haven't followed me on Twitch, please do so. I appreciate the follow. Keeps me motivated to do what I'm doing for y'all. Thanks for keeping me company. Lawtib, thanks for the interesting snake question. I've never made snake before, and it was fun to think about how one might do that. So thank you for your question, keeping me company. And yeah, I will see y'all, I guess not bright and early. It's halfway through the day. I will see y'all at 12 p.m. Eastern tomorrow. Awesome. I look forward to seeing you next time. Take care, chat.